On this episode of Assignment Discovery, look back to the beginnings of our universe in Hubble, Secrets from Space. Learn how the Hubble telescope records phenomena billions of light years away and see some of these remarkable pictures of the past. Finally, watch the Daredevil rescue mission by astronauts who saved the Hubble mission from disaster. And watch for questions, activities, and resources after each segment. Consider this before viewing Hubble, Secrets from Space, Part 1. What do you already know about the Hubble Space Telescope and how it has changed our understanding of the universe? While you watch the documentary, pay attention to how much of your existing knowledge is accurate. Keep a list of the ways that the Hubble and its findings affect your daily life. Then, predict how it might influence life in the future. Assignment Discovery now presents Hubble, Secrets from Space, Part 1.
These are images from space, slices of the universe put under a microscope. Images of new life and haunting images of destruction. They may give us clues about our place in the cosmos, where we came from, and where we're going. These are images from the Hubble Space Telescope. Orbiting just 330 miles above Earth, its view extends for trillions of miles beyond our corner of the universe to unlock secrets from space. Like an undersea creature roving the depths of the ocean, Hubble is perfectly adapted to the alien environment of space. For 15 years, it will soar above Earth's atmosphere to record the violent, often cataclysmic events taking place in the heavens. The death of stars, the birth of planets, the gluttonous appetite of black holes, the vital stardust that feeds solar systems, and life itself. We may even get a glimpse of what's in store for Earth in this erupting, exploding landscape of space. These are actual pictures Hubble has sent back from space. All these pictures are, in a sense, dated. They don't represent the present-day activities of stars and galaxies. They can't, because light, the light that makes these pictures, can only travel so fast through space. Light from our star, the Sun, takes 8 minutes to reach us on Earth. But most objects Hubble studies are so far away, it takes their light thousands, millions, even billions of years to reach the telescope and us. This exploded star left us a cosmic rose as it throws off its outer layers in an intricate dance. 3,000 light years away from Earth, we are seeing the Cat's Eye Nebula as it was 1,000 years BC. Eta Carinae, its light took 9,000 years to reach us. That means it is 9,000 light years away. The last outburst from this stellar bad boy was seen in 1843, when it became the second brightest star in the sky. With the delicate appearance of blown glass, this is the Hourglass Nebula. Hubble sees the hourglass 8,000 light years away, as it was when mankind still lived in the Stone Age. So Hubble is, in essence, taking pictures of the past. Astronomers can sift through these fossil records like archaeologists, searching for clues to what took place when the universe was a younger age.
We've always been interested as a species, maybe more than interested, obsessed with the idea of where did we come from, how do we fit into this universe? But science is giving us a whole new method of discovering, reading from what's written in the stars where we actually came from.
The story of the telescope's namesake goes back to Southern California in the 1920s. Early in the 20th century, astronomers still believed that the universe consisted of our Milky Way galaxy and nothing more. That concept was shattered by a dapper young astronomer, a star athlete and Rhodes Scholar named Edwin Hubble. While working at the Mount Wilson Observatory, he made one of the greatest scientific discoveries of the 20th century. The universe is composed not just of the Milky Way galaxy, but of countless galaxies. And those galaxies are speeding away from each other because the universe is expanding.
Before Hubble, there was a lot of debate about the universe. The most current theory in those days was that the universe was steady state. That is, no matter where you looked in space or time, no matter how far you look back, the universe more or less looked the same. It didn't evolve. Hubble gave us an expanding universe, and his observations really led to today's modern cosmology.
Hubble found that not only were the galaxies speeding away from each other, but the further away the galaxies, the faster they were moving away.
And it only takes a little thought to realize that a situation in which everything is moving apart from everything else, and the greater the distance, the more rapid the expansion, is just the situation you have if you start everything out with an explosive-like event and throw everything out. If you could run that movie backwards, you would see that everything came from one event, which we now refer to as the Big Bang.
Sharp observations made from a sharp telescope placed young Edwin Hubble next to the great minds of the century. A curious Albert Einstein, whose theory of relativity was partially confirmed by Hubble's observations, paid a rare visit to the astronomer's mountaintop. Hubble proved a telescope could look back in time to view the history of the universe. But that history would be muddled as long as telescopes remained grounded on Earth. Earth's murky atmosphere distorted the picture of space and blurred the truth. But a telescope above the Earth, that would give astronomers a clear way to see forever. Astronomer Lyman Spitzer proposed the idea for a space telescope in 1946, but many considered this a notion only for dreamers, science fiction.
I think almost all of my friends took a rather skeptical view of astronomical research out in space. They thought it was basically impractical, pie in the sky.
Pie in the sky or not, a telescope above Earth's atmosphere would provide amazing clarity. During the Cold War, the space race heated up. Spy satellite technology was designed to look down, not out, gathering secrets from the Earth. Astronomers wondered what greater secrets could be revealed if the lens were pointed away from the planet. The Hubble Space Telescope is the result of more than 20 years' work by some 10,000 scientists and engineers. Many of the scientists involved with Hubble dedicated major portions of their careers to the project.
It seems I've been involved for forever, and I wouldn't have done that if I didn't think that the payoff scientifically would be big.
Minus 10, go for main engine start.
April 1990, the launch of the Hubble Space Telescope, a payoff for almost a generation of labor.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
The hopes of thousands of astronomers ride into space on a trail of fire.
Discovery Houston, performance is nominal. Rendezvous, we're go. Fido, go. Eagle, go. Econ, go. Inco, we're go. FAO, go. EVA, we're go. Sergeant, you're still go? Go. Capcom, we have a go for release. Discovery Houston, go for Hubble release.
Okay, Story, we we've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to state.
Soon after deployment, Hubble would make front-page news all over the world, but it would not be the news the astronomers expected. Chris Burrows looked at the first pictures and knew something was wrong.
So of course we were very excited to see what the Hubble would finally produce. And the very first image we got was this. We were very glad to see that this double star had been separated into its two components, but each of the components was surrounded by fuzz. And that fuzz was the first hint that we had a problem with the optics.
The primary mirror of Hubble had been incorrectly ground by 1/50th the width of a human hair. This small error was enough to cripple the $2 billion telescope.
How could the science fail? How could there be a flaw? And what is it there about our system that doesn't identify the flaws until way, way, way late in the game?
Like many, it was one of the dark days of my life.
It was horrible. You know, I was new. I'd only spent at that point, maybe 5 years of my life doing that. Many people at that point had spent over a decade of their lives. And here, it just wasn't going to let us do the sorts of things that we had always hoped to do.
It was really a stain on the honor of the astronomy community and of NASA to have launched this very expensive telescope and to have this most fundamental of errors, spherical aberration in it.
The mirror is a beautiful mirror. It's got a lovely shape. It's wonderfully smooth. It's just the wrong shape. But because it's such a beautiful mirror, it was possible to build instruments that would use that wrong shape and still make good images.
Hubble would receive 2 sets of tiny mirrors, eyeglasses like these. The hopes and dreams for Hubble and for space astronomy would rest on this audacious proposal for a fix. December 2nd, 1993. The stage is set for the gutsiest shuttle mission in history, the rescue and repair of the Hubble Space Telescope. NASA has assembled a crew of its best and brightest, including the astronaut's astronaut, the payload commander, 59-year-old Story Musgrave, who brings his skills as a surgeon to the delicate operations ahead.
I am really frightened by this. I am both very scared and I'm very confident. If you ask me how it's going to turn out, if you force me to bet on it, I would bet on it that we would get everything done. This is a drama, and it's got to unfold.
The mission, 5 spacewalks in 5 nights to repair Hubble's delicate optics. While America is in an early winter slumber, the shuttle leaves behind the evening lights of South Florida. The main work on Hubble will all be done at night to protect the telescope's instruments from direct light. Direct sun could fry Hubble's innards.
We're ready to go grab that thing.
I bet you are.
While hurling around Earth, the 100-ton shuttle must track down and grab the 12-ton telescope.
And you've got to go for capture.
Once Hubble is in the astronaut's sights, the delicate task of reeling in the telescope begins. Story Musgrave reacts to his first sight of Hubble in space.
First reaction is how beautiful the thing is. It's just a gorgeous spaceship. You just look at it with respect. You look at it almost as if it has personality. I mean, it's awesome.
Endeavour has a firm handshake with Mr. Hubble's telescope.
We copy that, Cubby, and there are smiles galore down here.
It's quite a sight.
Hubble has logged some 500 million miles since it was last touched. With its multiple layers of insulation, Hubble weathers the extremes of space, searing heat in the sun, Arctic cold in the shade.
Sounds like a good plan, Endeavour. Good morning.
The astronauts float into this hostile landscape, a long list of repairs ahead. The blackness of space surrounding them makes it easy to forget this is a high wire act, 330 miles above Earth. Story Musgrave and Jeff Hoffman change out the telescope's wide field and planetary camera. This is Hubble's main camera.
Easy to keep it centered.
A small mirror at the end intercepts starlight. Musgrave is in an area where a fingerprint or a speck of dust could be devastating for Hubble.
6 inches in front of my face is where the mirror is. The stake is, if I touch that mirror, my fingerprint's going to be on every image that comes down.
Put it down lower.
That is not good form.
Look at the,
you know, it'll be immortal.
The camera slides like a drawer into a slot on the side of Hubble.
Looks like it's in there. Okay.
I drove tractors at the age of 5. They would leave me on a tractor at sunrise, come get me at sunset. If it broke, I had to fix it. And that's what we did. We were mechanics.
All right. Great. Well, I think we hopefully have a lot of eager astronomers ready to use this beautiful thing.
Astronauts Tom Akers and Catherine Thornton install corrective optics for the telescope, housed in a box the size of a telephone booth. Eyeglasses for Hubble's cameras are in their hands.
Drive this thing up in place. I'll go real easy here. Let's do this.
Thornton and Akers change out the solar panels, Hubble's power source. But first, Thornton must jettison a damaged panel.
Hey, no hands.
There's going to be 20 pulses on the RET for a set burn. Okay.
It looks like a burner, Tom. Look at it.
It's too early to celebrate. This may be the toughest job to perform. Hoffman and Musgrave work with small screws for Hubble's electronics. Their spacesuit gloves are awkward for the task, like using baseball mitts to repair a Swiss watch.
The screw is gone.
A tiny screw tumbles away from the astronauts. This wayward screw could be disastrous for Hubble's optical surfaces. If it nicked the mirror, it could mar the telescope's view of the stars.
I have it.
Okay, arm stops.
Great.
Good job.
The problem is fixed. Hubble is almost ready to be sent on its mission. But then, more trouble surfaces.
It's not closing. The doors aren't closing right. Let's try to get the bottom.
If the door doesn't shut, the guts of the telescope will be exposed to light.
But immediately flashing through your head, if you don't close those doors, you lose the telescope. You lose the telescope.
If we put a PID across here, and you could start the bolt up there, and we could watch it go together.
I think we got the door closed.
All right.
With Hubble on its way, the astronomers wait for the first images from the telescope. Their day of reckoning has arrived.
All of us were packed into this not terribly spacious room around maybe 1 or 2 computer terminals watching as everything came in.
It was an incredibly intense time.
What was at stake was, for the most part, the credibility of the program. It was quite a head rush, to be honest.
And I think when I look back on my career, I doubt that there will be another high to compare with being one of the people to stand there in front of all of our colleagues and say, this time we got it right.
This is a Hubble picture of a galaxy before the repairs. This is the same galaxy after the repairs. Hubble was back, ready to turn its full arsenal of cameras on the stars, providing images of stunning clarity. These are images of our nearest neighbors, the planets in our solar system, taken with Hubble's crisp new optics. With new eyes, Hubble is now letting us see how these planets change over time in a way that was impossible before.
I had been looking at Neptune with ground-based telescopes for years, and so I knew what Neptune looked like. But when I got my first Hubble pictures, the planet looked completely different. Every time we look, we see something new. New clouds are there, old clouds are gone. prior to Hubble, we pretty much assumed that the Voyager pictures of the giant planets in our solar system really were what those planets looked like. But with Hubble, we can actually see that these planets change, not in very subtle ways, but often in very dramatic ways.
These are the next astronauts who will touch Hubble. They will work as surgeons and as mechanics to improve Hubble's vision. These underwater simulations allow the astronauts to practice placing new cameras into the Space Telescope. But there is a great risk in introducing the human touch into Hubble's environment.
We weighed all those risks. We've even gone to the scientific community, said, is the increase in science worth the risk of messing around with something that's working really well now? The answer was a resounding yes.
7 astronauts are being outfitted for the mission. Each brings a different area of expertise, but all undergo similar training. 12 months are spent preparing for the 2-week journey, and it's a grueling year. Much of the time, the astronauts are physically and psychologically tested in life and death scenarios.
Did you get that thing over these broad shoulders?
They'll find time for a few lighthearted moments.
Get the helmet on.
But the dangers of space travel are never minimized. This virtual reality simulator helps to guide the astronauts through the repairs ahead. The mission? To put 2 new instruments into the Space Telescope, an infrared camera and a new spectrograph. These new instruments are intended to extend Hubble's vision just a little bit further into wavelengths not visible to the naked eye. The Hubble Space Telescope is the story of the best of American technology being used for the highest of purposes. Hubble is also the story of adversity overcome and of persistence in the face of huge obstacles. Space Telescope developer Lyman Spitzer.
My mother used to say, Lyman, anything you really want to do, if you work hard enough, you can accomplish. And that has been true in this case, thanks to some good luck.
When this telescope was conceived of, I was not even a twinkle in my parents' eye. I have been tremendously privileged to be able to use the Hubble Space Telescope. You can only feel honored that you've been allowed a little bit of time to look at your project, to look at your planet, to look at your galaxy.
You know, you may say it's irrational, but the fact that I have touched that machine, that I've worked on that machine, it has given me a much closer touch with astronomy and cosmology. It's the quest. It's the calling. It's what it is.
Now that you've seen Hubble, Secrets from Space Part 1, talk about this. The Hubble Space Telescope cost $2 billion and took more than 10,000 scientists and engineers over 20 years to build. Weigh the costs and resources that went into building the telescope against the insight that its findings have allowed. Are scientific projects like this worth the investment? Now try this. To simulate the challenges facing the astronauts who fixed the Hubble, put on a pair of thick winter gloves and try to screw together a nut and bolt. Don't forget that the slightest error on the real rescue mission could have jeopardized the entire project. To learn more, Assingment Discovery suggests the best of the Hubble Space Telescope at this internet address. Consider this before viewing Hubble, Secrets from Space, Part 2. Compile a list of as many possible uses for the Hubble Space Telescope as you can. Then while you watch the documentary, keep track of how the Hubble has been used so far and any plans for the future. Include both the ways you thought of and those that you didn't consider. Take note of what it means for the scientific community when Hubble data do not confirm popular theory. Assignment Discovery now presents Hubble, Secrets from Space, Part 2.
July 1994. Hubble tracks the Shoemaker-Levy 9 comet, its fragments strung out like pearls on target to collide with Jupiter. The impacts could be a replay of those that killed the dinosaurs on Earth 65 million years ago.
I was very skeptical. I thought there'd be nothing in those pictures except regular old Jupiter. I was very nervous because that was my very first program using Hubble. I remember being down in the control room when the first image appeared on the screen, and we knew that it was something to do with the impact, and we were all just flabbergasted. We were cheering and jumping up and down and just didn't even know what to think. What we learned from the Shoemaker-Levy 9 impact was that even small comets can make very large effects. I think that most of us had not really appreciated how tremendously large those effects would be. Hubble is so important to us in that respect because it's opening new windows and allowing us to find answers to questions that we never even thought we would be asking.
What happens when Hubble is turned far outside our neighborhood on other objects, thousands of light years away from us, mere specks in the night sky? The Crab Nebula, located in our Milky Way galaxy, harbors the tattered remains of a huge star explosion. Before Hubble put the Crab under its lens, astronomers never expected this dead star to be so lively.
The Crab is just this wonderful, neat astrophysics experiment all in one package. There's something there almost for everyone. For example, this material that was blasted into space, all of the elements that were formed as a result of nuclear processes inside that star are contained in those filaments of ejecta. It's where the atoms that you and I came from, events like that.
At the heart of the Crab is a violent piece of astrophysical machinery, a pulsar. This is a collapsed star 6 miles across, but it weighs as much as our sun and emits the energy of 130,000 suns. The Hubble Space Telescope has photographed the Crab over time and produced extraordinary images. The first space movie showing wispy waves pushing out from the center of the Crab Nebula.
So the net result was that the Crab Nebula is certainly dynamic, but probably much more dynamic than any of us probably thought it was.
These space waves move away from the pulsar at 90,000 miles per second. Hubble shows the Crab may be a model in miniature for what happens on a huge scale at the center of galaxies with active energy sources at their cores.
The Crab Nebula really illustrates what Space Telescope is all about. It's giving us that kind of a new, fresh look at phenomena throughout the universe.
Hubble provides a fresh perspective because it sees differently than we do. Hubble's 2 cameras and 2 spectrographs detect and analyze different properties of starlight. Along with visible light, Hubble sees light we can't see, ultraviolet light, the kind that gives us a sunburn, and infrared light, the kind that gives us warmth from the sun. Starlight entering Hubble carries vital information, clues really, about the star's temperature and chemistry, its speed and direction of movement. Operating above Earth's atmosphere, Hubble is so sensitive it could detect a candlelight in Tokyo from as far away as Los Angeles. In orbit, moving at 5 miles per second, Hubble sends its pictures in digital form to a communications satellite and eventually to a NASA relay station in the New Mexico desert. Command and control of the telescope takes place at the Operations Control Center at Goddard Space Flight Center. From Goddard, Hubble's imagery goes to the Space Telescope Science Institute, the center of Hubble's astronomy operations.
This is where we get to see in real time what the spacecraft is doing. And if needs be, we can tell it to change what it's doing. Repoint it, for example, to get a target exactly where we want it to be. The pointing precision required is exquisite in order that the small region of the sky that we're looking at not get shifted about and blurred during the images.
The guidance system on Hubble allows the telescope to locate known stars and follow objects in the sky with great accuracy. Once Hubble has found its target, observations begin. Astronomers never put their eye to the telescope, as in Edwin Hubble's day. They receive their pictures over the internet or in the mail on a digital tape.
Well, you know, every time you look at some object, many of these objects are old friends which you've studied for years. And when you look at them with the Hubble, suddenly you're able to see them much more clearly. So there's this enormous excitement when the data comes in. You don't know what you're going to see.
This is an old friend, Orion the Hunter. Turns out Orion has a maternal side. Somewhere inside his sword lies a vast celestial nursery where stars are born. The Orion Nebula. The stars here, some 3,000 of them, are less than 1 million years old, mere infants in astronomical time. Hubble focused its lens on more than 100 of these newborns. To the uninitiated eye, these stars don't look very remarkable. But astronomer Bob Odell suspects these stars yield something extraordinary.
What we found was that many of the stars looked funny, fuzzy. These stars were fuzzy because there was this halo of material around them.
The halo is a mix of dust and gas. Astronomers believe these rings are the beginnings of new planets taking root. These images may mirror our own beginnings. In the Orion Nebula, perhaps another planet Earth is growing.
So we're probably seeing what our solar system looked like when it was less than 1/2 million years old. And to be the first, at least human being, to see those objects is just a thrill. It's a form of exploration. It's like the great voyages 4 centuries ago, to sail over the horizon, knowing something interesting will be there and finding it.
The landscape of the frontier, part of our collective dreams of Western movies and unknown territories. Curiously, these ghostly desert spires look like miniature replicas of the Eagle Nebula, an area which Hubble has shown to be anything but barren. 7,000 light years away from us, the Eagle is in fact a star hatchery, a nesting ground where prenatal stars are incubated. The tall columns in the picture harbor newly forming stars, partially hidden in the small nodules. Each embryonic star is surrounded by a protective egg of gas and dust, about the size of our entire solar system. These eggs feed the growing star until it has gained enough weight to trigger a thermonuclear reaction required for star birth. But not all these stars will hatch.
Each one of those little eggs were being uncovered, and in the process, the stars that were forming inside of it are being cut off from the material that they're forming from. And we seem to have discovered a process that people hadn't really seen before. When we look at the processes that we're studying, processes of star formation, processes of elements being formed and ejected back into space, the elements that we're made out of. It's looking at our roots taken to the extreme.
Stars are born and stars die, even our sun. Though its place in our lives seems constant, even infinite, the sun will burn out and die in 4 or 5 billion years.
Stars have a life cycle just like humans. And when they use up all their fuel, the star collapses down into something about the size of our Earth. A teaspoon of it would weigh a ton. But when that happens, the outer part of the star is thrown off and becomes a planetary nebula. It has nothing to do with planets.
This is how the sun will end. But stars die in different ways, depending on their size.
Stars more massive than the sun, stars with masses of 2 to 4 solar masses, will end up as neutron stars. And again, the mass will be comparable to that of the sun, and this time it will be smashed down into a volume just a few kilometers across.
But first, these massive stars explode in what is called a supernova, increasing their brightness 1 billion times. In another galaxy next door to the Milky Way, supernova 1987A, named for the year it was first spotted. Astronomers were totally surprised at this Hubble image.
What we thought we would see would be sheets of material which have been blown off this star, but instead we see these 3 rings hanging in space. The explosion itself is right in here, and you can see, in the Hubble images, you can see this cloud of gas expanding out towards the inner ring.
This expanding inner ring will soon collide with the outer rings. But the larger rings are the real mystery in this picture.
But we really have no idea how they got there or why they're there. And despite the theorists' best efforts, we still don't have a good understanding of what went on with this star before it exploded and how it came to form these 2 big smoke rings in space.
Dying stars sometimes leave bizarre signatures. These images are from the Helix Nebula in the constellation Aquarius. At first glance, they look like something we might see under a microscope, tadpoles twisting through a galactic pond. But these tadpoles aren't tiny. Each tail stretches 100 billion miles. Curiously, these formations, called cometary knots, seem to be moving away from the dying star. They seem to be anchorless.
Each one of these clumps has several times the mass of our Earth in it. And that raises this interesting possibility that these clumps of gas could actually form solid bodies, planets if you want to call them that. If this is right, these are rogue planets, like rogue elephants roaming without an attachment to a particular herd.
It's still a mystery where these rogue elephants of the stars will go. But the largest stars of all may suffer the strangest fates. They turn into black holes. Hubble has turned its lens on what may be the first real look at this phenomenon. Black holes form when massive stars collapse on themselves. With such an immense gravitational pull, they create a whirlpool effect, sucking in everything behind them. Objects inside are crushed into a single small point, but one with far more mass than the sun. Nothing can escape the black hole's clutches, not even light. And without light, we have no way to see it. Scientists such as Holland Ford have long suspected that black holes lurk at the heart of certain galaxies. Before the Hubble telescope, there was no way of knowing for sure. Now Ford thinks he may have caught one.
We had a program to investigate the centers of elliptical galaxies. We were using the Hubble Space Telescope to take pictures of these galaxies, and quite unexpectedly, what we found in one of these galaxies was this beautiful dusty disk, and we were just directly seeing what looked like the classical description of a black hole being fed by matter in the center of a galaxy.
What Ford discovered was that the core of the galaxy was spinning at a high rate of speed, like a supersonic merry-go-round. Normally, this galaxy should have flown apart. Its center was moving so fast. Something was anchoring it. The only thing with enough gravitational pull to hold the galaxy together was a black hole, more than 1 billion times heavier than our Sun. Hubble also captured this, a jet 40,000 light-years long that appears to spew out of the center of a black hole. Scientists think these are the sparks that fly when stars and other such matter collide, as the black hole draws them in.
It was very exciting, and I also thought that, we were finally realizing what HST had been launched to do.
When we look out into space, we see galaxies, great armadas containing billions of stars. Without galaxies, there would be no stars, and without stars, no life in the universe. This is a Hubble image of a nearby galaxy, the Cartwheel Galaxy. The picture shows a cosmic collision of huge proportions. Galaxies collide here, creating a tidal wave of starburst formation in the ring, and the possibility for new life. This Hubble picture clearly shows the shapes of galaxies when the universe was much younger.
I remember taking these slides to various conferences and just flashing them up, and you could hear sort of audible gasps in the room of, wow, that's the universe the way it used to look. Isn't that exciting? Here's a picture of the universe 5 billion years ago.
Hubble is pushing even deeper into the universe.
Got a couple of color images here, Roger.
A new image from Hubble. Astronomers Sam Pasquarelli and Roger Windhorst have taken photos of primordial clumps of matter shortly after the Big Bang as they coalesce into galaxies.
The predecessors of the galaxies that we see today has been sort of an astronomer's holy grail for years. And we were more than surprised when we found out that there were 18 objects in our field that seemed to be at the same distance of about 11 billion light years.
Hubble is showing us for the first time the beginnings of galaxies. Over time, these shreds of galaxies, clumps of perhaps 1 billion stars each, will collide and merge into the giant galaxies we see today. We are watching ancient history. We can only guess how this part of the universe looks now. Hubble is looking back not just at the birth of galaxies, but at the biggest birthday of all, the birth of the universe. It does this by supplying data on Earth's distance to other galaxies and the speed at which those galaxies are moving away. Edwin Hubble himself devised these formulas for figuring out when the Big Bang occurred. But why should astronomers need to know?
If you're a patient going to a doctor, one of the first things the doctor is going to want to know is how old are you? If you can't tell the doctor whether you're 30 years old or 60 years old, that might change their diagnosis of the problem you're having. They need to know your age to help in their diagnosis. Same is true of the universe.
At one time, astronomers believed the universe to be at least 15 billion years old. But the data from Hubble produced odd results. The universe came out younger than expected, 8 to 12 billion years old. Younger, in fact, than some of the oldest stars seen in a cluster like this one. The numbers weren't adding up.
This is a paradox. How can you have a daughter who's older than the mother? So this is creating a real problem in cosmology. Either we don't understand fully the consequences of the Big Bang. It doesn't prove the Big Bang's wrong. It means we might not understand all there is to know about it. Or we don't understand something even more fundamental, and that is the age of stars. We've been studying stars for decades. We've got a star called the Sun that's very close. And we thought we really had that nailed. We thought we really understood how stars age and we could measure their age. If we did that wrong, then we've really got some problems.
Astronomers are back at the drawing board trying to reconcile the conflicting evidence. While Hubble has upheld certain cherished notions about the universe, it has shaken others. This too will be a part of Hubble's legacy. What would happen if we pointed Hubble as deep as it could look into the faintest, most distant reaches of the universe? What would the picture look like?
The deep field image is just a flat picture when you get it. It's a two-dimensional picture of a very, very three-dimensional universe. Four-dimensional, really, if you want to talk about the time element, which is what we're really interested in. It's a very carefully chosen random spot on the sky. What we were trying to do was avoid things, really. So we wanted to get away from bright stars, we wanted to get away from the gas and dust in our galaxy that would obscure our view of the distant universe. The Hubble Deep Field is sort of the peak of the pyramid. You're looking at something that is the size of a grain of sand held at arm's length. I think that just sheer number of galaxies that you can see is, to someone like me, breathtaking.
This is the deepest image of the universe ever taken with a telescope. Scientists dubbed this area the Hubble Deep Field.
So the game here is to find ways of unfolding this picture and finding out what's far away, what's nearby. Because what we want to do is not just study galaxies because they're far away, but because you're looking back in time.
Our origins, and perhaps our destiny, lie in the stars. We can imagine what other worlds the stars have created, and if there are other thinking creatures out there. The Hubble Space Telescope allows us to stab into space, to try to piece together the story of our beginnings. A new program with Hubble carries on this search for life, the Origins program.
Hubble is really the first step in the Origins program. It's the only mission up there right now that's doing that kind of science. So our goal is to really go out and image other Earth-like planets around other stars, and even more importantly, analyze their atmospheres to look for tracers of life.
The universe is an awfully big place, and if we're the only ones around to appreciate it, that's kind of a waste.
In space, even greater mysteries certainly lay hidden from us. But these pictures bear witness that we are a people who looked into the stars with Hubble and asked, what is out there? Where do we come from? The telescope will continue to turn an unblinking eye on the cosmos, revealing new secrets from space. Perhaps the best is yet to come.
Now that you've seen Hubble's Secrets from Space Part 2, talk about this. NASA's Origins program seeks to find and study habitable planets in our solar system and beyond. The program is looking for evidence of life, or even the possibility of life in distant galaxies. Do you think this is an important project? Debate whether or not it is a good use of the Hubble Space Telescope. Now try this. With your class, form 3 research groups. Choose one group to be the Hubble decision makers, while the others present cases for how the telescope should be used. After the decision makers choose a project, discuss the difficulties of this process. To learn more, Assingment Discovery suggests the Space Telescope Science Institute at this internet address.